Hi class, sorry I wasn't here today, but here are some video notes for you to follow along with for this PowerPoint to go with the guided notes that you can take as you are watching this video. So today is the final review part 2 for units 3 and 4. Our essential question is, how can I identify the vertex and axis of symmetry in vertex form and standard form? And how can I factor a quadratic equation and find the x-intercepts of a quadratic function? So going to slide 2, we can look at our objectives today. You guys will be able to identify the axis of symmetry and the vertex in standard form, but also in vertex form. Students will also be able to factor quadratic equations to identify x-intercepts. Your language objectives are you guys will be able to explain the steps involved in factoring quadratic equations, and you'll be able to explain how to find the vertex and axis of symmetry from vertex form and standard form. So I have a I try, we try, and then you will try with our practice today. So I was going to show you how to find the vertex and the axis of symmetry out of vertex form. So what is vertex form? Our vertex form is y equals a parentheses x minus h squared plus k. We've seen this before. This is just a review. Yes, a is still actually the same as what we have previously noted. That is our vertical stretch and compression. And if a is positive, it tells us that it's going to be a upwards u versus a downwards u if it's negative. The h value, though, tells us if it's going to move the function to the left from the origin or to the right if it's negative. Finally, k moves our function either up from the origin, 0, 0, if it's positive, or down if it's negative. So how do you find the vertex and the axis of symmetry? Well, in vertex form, again, it's to our right here. If we're given the example of y equals 2 parentheses x minus 3 squared plus 4, the first step I would want to do is identify the h and the k. Here, our h is negative 3 and our k is 4. So to identify the vertex in step 2, all we would have to do is take the opposite of h. And so for the opposite of h here, it would be positive 3. And we just take k. K is as what it is 4. So our vertex would be negative 3, 4. If you're going to identify the axis of symmetry, though, we're going to use the axis of symmetry is equal to the x value of our vertex. So whatever your x value of your vertex is after you find it, that is what your axis of symmetry is. And it is written as an equation of x is equal to h, in which case h is just referring to the x value of our vertex. So here our value of our vertex is 3. So our axis of symmetry would simply be x is equal to 3. I have an example for you. So in this case, find the vertex and the axis symmetry of example number 2. Y equals negative parentheses x plus 1 squared minus 5. Again, your first step is to identify the h and the k. On your paper, sorry. Well, I already gave it to you, but I'm pretty sure you can identify that the h is 1 and that the k is negative 5. Well, again, we want to be able to identify the vertex here. So again, we want to take the opposite of h, in which case, on your paper, right, what would the opposite of h be? If you wrote negative 1, perfect. Again, we're just taking the opposite. If it's positive, now it's negative. So it'd be negative 1, and then our k value, which is negative 5. So our vertex would be 1, negative 5. And that would be our coordinate point for our vertex. If we're going to find the axis of symmetry, again, our axis of symmetry is just the x value of your vertex. On your paper, go ahead and write down what you believe the x value of the vertex is, or what the equation of the axis of symmetry should be. If you wrote x is equal to 1, you are correct. Again, we are just taking the x value of the vertex that we just found, in which case it's 1. And it is written as the equation of x is equal to the value of 1. Now I want to try to show you how to find the vertexes and axis of symmetry out of standard form. So what is standard form? Again, I know it's on the board, but our standard form is y is equal to ax squared plus bx plus c. Yes, we have been working with this with factoring, but I at least wanted to revisit the idea of what is standard form. So to find the vertex, in this case the question is posed, how do you find the vertex and axis of symmetry? We're going to use the example of y equals 2x squared plus 4x plus 2. And yes, I will walk through the steps on how to find the vertex and axis of symmetry. So steps. The first step is to find the x value of the vertex. And yes, it is the equation that we're going to use that's in red, which says use the equation x is equal to negative b divided by 2 times a. So what I would do is write the equation again right below my example, x equal to negative b divided by 2a. And I have an arrow pointing because I would want to input the b value here and the a value. And since we've been doing this so often with factored form, again, we know it's just the coefficients that are sitting in front of the x squared and the x. Our b is sitting in front of the x, which is 4, and our a is sitting in front of the x squared, which is 2. So I'm just substituting the value for b as 4 and a as 2. So I should have the equation negative parentheses 4 divided by 2 times 2. And again, I like to use parentheses around my b value because sometimes it is negative. If it is negative, then we would have to multiply the negative times the negative and make it a positive. But here, we just have a 4. So we'd make it a negative 4 over 4 because 2 times 2 is 4. So we have the fraction of negative 4 divided by 4. And again, I use the word divided because we are dividing when we see a fraction. So negative 4 divided by 4 is negative 1. That would be the x value of our vertex. And that's by using the equation negative b divided by 2a. So second, to find our y value is to substitute the x value you found into the original equation and solve for y. So I would rewrite my equation as y equals 2x squared plus 4x plus 2. And first, I would want to substitute the x value here. To substitute the x value, again, all I'm taking is negative 1, the value I found, and substituting it into both the x values of the equation. So I would rewrite it as y equals 2 parentheses negative 1 squared plus 4 parentheses negative 1 plus 2. And again, I have parentheses to indicate that I'm going to be multiplying those after I simplify. And the first part of simplifying is dealing with the exponent. So we actually have negative 1 squared. So negative 1 times negative 1 would turn into positive 1. So my equation now is y equals 2 times 1 plus 4 times negative 1 plus 2. Now my third step would be to multiply. I would multiply 2 times 1 and 4 times negative 1. 2 times 1 would give me 2, and 4 times negative 1 would give me negative 4. In this case, I would have, I can't move that, but we would have y equals 2 minus 4 plus 2. And then I would also have to simplify that by adding and subtracting the numbers given, in which case I have 2 minus 4 plus 2 would give me 0. So my vertex is now just the x and y value that you just found. Again, the x value was negative 1. The y value was 0. So my vertex would be negative 1, 0. I know my face is kind of blocking it. Hopefully it doesn't do that for your guys' video. But again, I found my x by using the equation x equals negative b divided by 2a, substituting the values of b and a, and then solving for that, in which case I got negative 1. Then in step 2, I took that value and substituted it to the x values of my equation. I simplified. As you can see, I walked through steps 1 through 4 of substituting, exponents, multiplying, adding and subtracting, in which case I found 0. Finally, I would need to find the axis of symmetry, and just like our vertex form, it's equal to the x value of my vertex. So in this case, my axis of symmetry is written as an equation of x is equal to, in this case, -1. So we're going to try one together to find the vertex and the axis of symmetry out of standard form. So again, to find the vertex and axis of symmetry, I'm giving the example of y equals x squared plus 6x plus 5. So our first step is to find the x value of the vertex. Use the equation x equals -b divided by 2a. Again, I want to write this underneath my equation where I would write x equals -b divided by 2a. And I would substitute the values that I have for a and for b. Go ahead and identify those two values and substitute it into your equation. I'll give you a moment to do so. So here, our b value is 6, our a value is 1. So what I would substitute into this equation is negative parentheses 6 divided by 2 parentheses 1. Now I can simplify that into -6 over 2, because 2 times 1 is 2. If I was to divide -6 by 2, what would I get? Write that down on your paper. If you got -3, you were correct. So our x value of our vertex is -3. Now for step 2, to find the y value. Again, we're just going to take that x value and plug it into our equation. So our equation again is y equals x squared plus 6 plus 5. So I'm going to go ahead and give you a moment to substitute that x value of -3 and rewrite it into our equation. What you should have got was y equals -3 squared plus 6 times -3 plus 5. Again, I would want to follow the steps of first writing or solving the exponent first. So in this case, what is -3 times -3? Go ahead and rewrite this equation where you solve the exponents in the first term. If you got -3 times -3 is 9, you're correct. In which case I would rewrite this equation as y equals 9 plus 6 times -3 plus 5. Now my third step is to multiply. Now rewrite this equation after you multiply 6 times -3. If you got -18, perfect. So your equation should be y equals 9 minus 18 plus 5. Now our last step is to add those together and subtract. So what is 9 minus 18 plus 5? Go ahead and write your answer below. What you should have got was, in this case, 9 minus 18 is -9. -9 plus 5 is -4. So our y value would be -4. Now I know what my vertex is, which is the x value I found in the beginning, -3, and y being -4. So I would write it as a coordinate point of -3, -4. Finally, to find the axis of symmetry, just like vertex form, it's equal to the x value of our vertex. And we write it as an equation of x is equal to a number. What number is it equal to? Go ahead and write that below. If you got x is equal to -3, you are correct. And that would be our axis of symmetry. The reason why we're not going through and finding points to the left and right of our graphs and just finding the axis of symmetry and vertex out of both forms is because that is what most of the questions will be about, is finding the vertex and axis of symmetry. If you're able to find both of those, you should be able to answer any questions about graphing. Now it's time for us to move on to factoring. So here is an example that I was going to show you how I think about in using this flowchart that I've created for us. It's the same thing as using the big X, but I noticed taking the test that some of us had a hard time with using the big X. So here are some steps to follow through in solving and finding what our x-intercepts are and finding the factored form from standard form. So step 1 would be to look at our expression. Here we have 2x squared plus 4x minus 16 equals 0. So the first question is there a greatest common factor? Is there a GCF? Is there a number that goes into 2, 4, and negative 16? There is. So I look at my a value usually, and I can see that it's 2. So I want to be able to see if 2 can go into all three terms, in which case I can all 2, 4, and negative 16 are all divisible by 2. So in this case, I would circle yes in this flowchart. Now moving down from yes, we have step 2, which is to factor out the greatest common factor in front of the set of the parentheses. Meaning I would rewrite my equation here of 2x squared plus 4x minus 16. And then I would want to divide each term by 2. Again, after I divide each term by 2, I would take that 2 and place it outside the parentheses. And inside the parentheses is my simplified standard form. So 2 divided by 2 is 1, or x squared. 4 divided by 2 is 2, so 2x. And negative 16 divided by 2 is negative 8. That would be my new standard form that I would be using to factor. So we can see an arrow pointing to the right, to the right, which is a the coefficient of the x squared term positive 1? Actually, it is. There's an invisible 1 that's sitting right in front of it. So we would circle yes. And then we would move down from yes. On the next section, we have step 3, in which case we can look at the constant value c, in our case is negative 8, and the remaining quadratic trinomial. It wants us to list out factor pairs that multiply to this number. Use this table to determine the signs you need. Once you have your list of factors pairs, add together each of the pairs. So we have 4 different setups here. We have a setup of x squared plus bx plus c. We have a setup of x squared minus bx plus c. We have another one which is x squared plus bx minus c. And then on the bottom right, we have x squared minus bx minus c. So we're just trying to see which one looks exactly like the form we have inside the parentheses. In which case we have a positive 2 for b and a negative c value of 8. So the one that would be the bottom left one. In which case it tells us that the bigger factor that we find is going to be positive and the smaller factor is going to be negative. I also noticed that we had a hard time with this in our Unit 4 tests as well as factoring within our lessons. So I wanted to create this little chart to show you guys how we could use it. So in this case, we want to take our c value 8, or negative 8, and we want to find factors of negative 8. In which case, now we know that the bigger factor is going to be positive and the smaller factor is going to be negative. So in this case, we have the factors of negative 1 and 8. That works out. But also negative 8 can be factored into negative 2 and 4. So which one would add up to equal 2? Well, negative 1 plus 8 equals 7. And negative 2 plus 4 equals 2. That's the one we're looking for. The one that equals our b value of 2. So that one I would put a check on. Then I would move on to step 4. So looking at the coefficients of the x term b, find the winning factor pair from the last step that also happens to add up to bb, which we just did, but it verifies that you have found the correct factor pair by making sure that both equations below are true. So f1 and f2 are just factor 1 and factor 2. So for factor 1, we found that it was negative 2, and for factor 4, we found that it was 4, because negative 2 times 4 does equal negative 8, our c value. And factor 1, negative 2, plus our factor 2, 4, does add up to equal 2. So that checks off both boxes for us, just to ensure that we got the correct factor pair. Finally, for step 5, This allows us to write the factored form as x plus or minus factor 1 times x plus or minus factor 2. We don't want to forget to put the GCF in front, and that's if there was one, and then simplify if needed. So we have the factored form of 2, because that's our GCF we put outside, times x minus 2, our factored form 1, times x plus 4, our factored form 2, is equal to 0. And then we want to ask ourselves, did we use a slide method, which we'll go over as well. But in this example, we didn't have to use the slide method, so we would circle no. And we can always check our answer to make sure that we got it correct by first rewriting our factored form and then multiplying using the distributive property, which we learned in or retaught in the first part of the final review, where I would take x times x and x times 4 and negative 2 times x and negative 2 times positive 4. What I would get would be 2 times x squared plus 4x minus 2x minus 8. And then I would want to combine like terms. We see like terms of 4x minus 2x, and those are like terms because they have the same variable and the same exponent. So I would simplify that to 2 parentheses x squared plus 2x minus 8. Now I can distribute the 2 into all three terms, in which case I would get 2x squared plus 4x minus 16 equals 0. Perfect, we got right back to where we came from, and that would be how we use this flowchart. So we would want to be able to find the zeros, means that we want to find the x-intercepts using the zero product property. So again, we have our factored form of 2 times x minus 2 times x plus 4. And we have it equal to 0 because, again, we want our y to be equal to 0 so we can find the x-intercepts. So what I would want to do is write the binomial of x minus 2 equal to 0 and the binomial of x plus 4 equal to 0. And then I would want to solve for x. On the left, we have x minus 2. Again, getting x by itself means we're using the inverse operation. Instead of negative, we want to add 2. And what we do to one side, we're going to do to the other. In which case, we get x is equal to 2. On the right side, we know we're just using the opposite, which is negative 4. So we should get x is equal to negative 4. So those are our two x-intercepts. So if we're going to list them as x-intercepts, again, they're where they cross the x-axis, where y is equal to 0. So we would write it as 2, 0 and negative 4, 0. Now I have a we try factoring flowchart. So we have the example of x squared plus 11x plus 18 equals 0. The question is there a GCF? I'll give you a moment to answer that. I don't know if you noticed, but I clicked no by accident because there is no GCF. Anytime I see 1 as my A value or the invisible one, then I know that there is no GCF. So in this case, I'd go straight to no. So here, we don't even have to go to step 2 because we can skip it. There is no greatest common factor. And then the question is A the coefficient of x squared term positive 1? In which case, it is. So I can go straight down to step 3. And again, my equation that I have is x squared plus 11x plus 18. Go ahead and circle which one of the 4 boxes represents our quadratic equation. If you circled the top left box, you are correct. Our B value is positive, our C value is positive. So both factors are going to be positive. So we would have that top box highlighted. Now we would want to use our C value, 18, and be able to find the factors of 18 that also could possibly add up to 11. So the factors of 18 are 1 and 18, but also 2 and 9. We know that 1 plus 18 would equal 19, and we know that 2 plus 9 would equal 11. So the factors that work would be 2 and 9. Put a little check mark there. Now for step 4, we would want to just check to make sure that our factor 1 and factor 2 multiply to equal our C, but add to equal our B, in which case I would write 2 in the first box, 9 in the second. 2 times 9 is 18. That checks off. 2 in the first box plus 9 does add up to equal 11. Perfect. That checks off as well. So now we would want to write our factored form in step 5, where we write factor 1 and factor 2 after the x, in which case we would have x plus 2 and x plus 9 equaling 0. We didn't end up using the slide step, so we'd go straight to no, and we can always check our answer. Again, checking our answer would be to use the distributive property, x times x and x times 9, and then 2 times x and 2 times 9. I would get x squared plus 9x plus 2x plus 18. I would combine the like terms in the middle, which would be 11x. So it does check out here for us. So again, we want to find the zeros, or find the x-intercepts using the zero product property of the example we just used. So we would have x plus 2 times x plus 9 equal to 0. I'll give you a moment to try to find what both the x-intercepts are. Okay, so again, I should have put x plus 2 equal to 0, but also x plus 9 equal to 0. I would solve for both, and I know that I'm just taking the opposite of what it is. So I would have to subtract 2 to both sides for the left equation. I would get x is equal to negative 2. And I have to subtract 9 to both sides of the right equation, in which case I get x is equal to negative 9. So if I was to write this as coordinate points, I should have written it as negative 2, comma 0, and negative 9, comma 0. Those would be my two x-intercepts. That concludes our PowerPoint presentation, in which case I want to go over the last slide with you folks. Again, this concludes our notes for the semester. Sorry I wasn't here with you guys for the last day and to go over what the final is going to be about, but I hope this is a better supplement than me being there is too. But what you guys need to work on now is to finish off the final review practice 19 through 38. I know I said I would go over 19 and 20, but those are just multiplying polynomials. Both the polynomials they give you on 19, you're going to have to multiply. They say product, meaning to multiply. 20 is asking about a rectangle, meaning that you would take the area, which is length times width, and multiply both those binomials. For numbers 21 through 24, you do not have to graph those. All you need to find is the vertex and the axis of symmetry. If you're able to find both of those, you'll do perfect on the test. After you're done with that, work on the Delta Math final review if you feel not so confident in all the practice we've done. All late work is due on Friday, 12/15, which is tomorrow. So again, submit any late work to me so I can grade it over the weekend and make sure that you guys have your grades updated by going into the final on Tuesday through Thursday of next week. Again, study for your final. Good luck. If you have any questions, please send me an email or message me or come to class. Thank you.